Hi there, and welcome back to the Complete C Sharp Masterclass, where you'll go from coding zero to coding hero. Today on the agenda, we have dependency injection. We'll cover topics like what is dependency injection, why is it useful, what is inversion of control. We'll also have a look at different types of dependency injection, and then we'll cover what DI containers are, and we'll wrap it up with what service lifetimes are, including transient, scoped, and singleton. So, without further ado, let's jump straight into it. So, what is dependency injection? So, have a look at this here. We have a class and we have some sort of dependency injection item. The class says, hey, I need these two objects in order for me to perform my operation. Please give that to me ASAP. And then dependency injection just says like cool. And then in the background it goes and it creates these objects for you and it puts them inside of the container and it simply delivers them to the class. The class then uses that specific objects as it needs to and it simply goes over using them. So let's have a look at what it actually means. So dependency injection in programming is just a technique that makes a class independent from its dependencies. It achieves this by decoupling the usage of an object from its creation. This is important because it follows the solid principles, specifically dependency inversion and single responsibility. So it helps us to build code that's much cleaner, easier to understand, and something that's more loosely coupled. So we can simply take that service and then just reuse it in another item as we need to. So, why is it actually useful? So, dependency injection at its core is really just around three specific topics: being able to instantiate the objects, so creating them as needed. It knows what classes depend on those objects and is able to provide the objects to the dependent classes. So, dependency injection aims to separate the concerns of constructing objects and using them. So, this leads to more loosely coupled programs because we can simply just use an item without having to care about how it's created. This pattern ensures that objects or functions which return or use a given service should not have to know how to construct these services. This is a very useful pattern because then it makes code more straightforward. We don't need to care about newing something up. We simply say, hey, there's a dependency that we need, and the container simply just gives it to us. So, again, in terms of usefulness, dependency injection relies on various coding modules from tasks to instantiate resources, enable dependencies, we can mock dependencies, so we can swap out different dependencies quite easily. So, this is a really cool benefit because then we can go and test code. Another thing that's really awesome is it makes the code more maintainable and more reusable, right? We can easily just swap out items for what we need to. And it allows us to dev more as developers. We don't have to wait on somebody else in order for them to implement something in order for us to use it. We can simply just depend on the abstraction of that and then just assume that it works up until somebody's actually developed it, and then the rest of the code will work accordingly. This is also very useful for things like unit testing because then we don't have to care about the actual implementation. You can think of something like, let's say, a service that has products, a product service, and we need to be able to create orders. We might not necessarily have a database that stores all that information immediately, but we need to test the code if it works. So, how would you do that? Dependency injection is the answer. We can simply just create a swap out of a database and fake that data using a list or whatever other mechanism. And then we can test it without the need to actually have a database. So this makes code much more easy to use. We're following a standard practice that everybody else understands, and it makes code much easier to test and to build. So, what is inversion of control? So, of control is really a solid principle that basically says high level modules should not depend on low level modules. Both of them should depend on abstractions. And the abstraction should not depend on the details, but the details should depend on the abstractions. Now, I want to direct you to this image for a moment, and this is where we have low level modules and we have high level modules. These should not depend on one another, they should both depend on abstractions. So if you had to look at this would be what the actual interface is. So this could be one service that says, hey, my job is to perform certain operations. So if we think about the product service or the order service, maybe we want to place an order. We don't necessarily know about what the other items are down here in terms of their root functionality or implementation. We would just know, hey, from the product service or from the order service, here maybe an order line service that we need to call to create all the orders, to purchase all the products, to do shipping, to calculate taxes, and so forth. And we don't have to care about that because dependency injection simply takes care of that for us. By inverting the dependency to the service, to each of these modules independently, we can simply just assume it works and just call those services, which is a really awesome function about dependency injection as a whole. Okay, let's move on to the next one. So, what kind of dependency injection do you have? So, we have four main different types of dependency injection. One being interface injection, not as common. We have constructor injection, which is the most common, where we inject the dependency through the client's constructor. And then we also have setter injection and method injection. These are also very useful, but they're often not used very much. So let's look at a few examples. So here we have some sort of a notification service that goes and just is able to send a notification. We have three different implementations for them. We have a push notification, we have an email, and we have an SMS. Each of these sending out the notification. Then we have a notification service, and this notification just takes in the dependency into that. And then it goes and it sets that dependency into a private field. This is what we often refer to as constructor injection. We injecting the dependency through the constructor. Now this is useful because then we don't have to care about the rest of the items. We will just assume, hey, this dependency works, and we can just simply call it. We don't have to care about the physical implementation. It can be swapped out for any implementation of that iNotification channel whatsoever. Here we also have a set notification channel on the specific item. So this is how we would go about implementing something like a setter or method dependency injection, where we go and simply set the dependency through a method. And then we simply just call the send notification method with the message that it needs to send. So here we can have a look at three different kinds. So again, here we have the interface injection, which basically is very similar to the constructor injection. It just injects it through the constructor itself. And then here we have a setter. So here we're basically creating a notification service without any item to work, and then we simply pass that notification item via the method. And the same normally goes for being able to do method and setter. They're very similar, to be honest. It really just depends on what we need. The only difference is, like with a method injection, we're taking in the notification channel from the method itself to physically be able to action this. So yeah, that's just at a high level overview the difference between the types of dependency injections that we get and how we can use them. It's very useful to understand because then we can simply just know, hey, we need this service. We ask the DI container to say, give us the service, and it takes care of the creation. So this is often what happens under the hood with the dependency injection container. We'll go into more details around what a container is, what purpose it serves, and why is it useful for us. So in terms of how this would be set up, we would simply just call each of these methods. So here we would just build the item and it would just send the notification. And then the only really difference here would be that with the method one, we would go and create it outside and then set it in here. So yeah, that's at a high level the biggest differences between the four types. And again, these are really like high level approaches. More often than not, we'll really only be using constructor injection, mainly because it's a more easy way to construct objects. We'll be able to auto construct those objects using a container, so we don't necessarily have to worry about newing this up. So this is just how it would work under the hood. So let's dive into what an DI container actually is. So I want to direct your attention to this image here on the left hand side quickly. And this is actually what a container does underneath. So here we have three different types of shoemakers, and you can think of these as services. So these are the different services. They have a bunch of dependencies, and they simply say the container basically just says when the program starts up, hey, you services, you shoemakers, you're gonna need these items to do your job. And it simply just works. We don't have to care about the construction of how this works because the DI container will just simply create that in the background. Now, as to what a DI container actually is, it's just a framework for implementing automatic dependency injection. So it manages the creation of the objects, its lifetime, how it's injected into it. It's an object that basically just knows how to instantiate and configure objects and all of their dependencies. Yeah, so that's at a high level simply what a container, DI container is and what purpose that it actually serves. So a container must at default implement three specific methods. We must be able to register services. This is really just where we go and say, hey, for this abstraction or this interface, this is the implementation that we have. That's what we often call a type mapping. So it'll be from an interface to a concrete implementation. So that's the first part that it needs to be able to implement, because that's how we tell the container, hey, this is the services that we have. These are the mappings between the two services. And then it has to have a resolver. So the resolver actually goes and creates these objects in the background, depending on what the use case is. If we go and say maybe depending on the life cycle, like is it scoped, is it transient, is it singleton, and then it basically just resolves it. So it's like, hey, I can create these objects, it creates the objects, and then it simply passes them to wherever those dependencies are required. So that's that step over here. It will create these objects in the background and say, hey, you'll need these, and it passes it to the respective items. That's where the resolver comes in. It does this automatically in the background. And then lastly is the dispose. So this is really about the life cycle and how we register this. So we'll dive more into like what are the different types of lifetime cycles that we have. So if it's, for example, transient, it will constantly dispose of them for every new item that comes in. If it's scoped, it will reuse the same item throughout the life cycle. And if it's singleton, it will use it throughout the entire application. But we'll get into more detail around what that actually does. Okay, so these are the three. So yeah, just some common DI frameworks in .NET. The three most common ones that are often used in .NET is the built-in one, the service collection. This is by far one of the lightweight, easier to use DI containers in .NET. And then we also have Ninject, we have Autofac. These are just ones that you need to be aware of. They are commonly used as well. Some other alternatives are here like Unity, Light Inject, Simple Inject, Castle Windsor, Structure Map. There's a bunch of others out there as well, but again, these are the three most commonly used DI containers. Just simply because of the support and availability of it. There's a very large community around these three, so I would suggest using one of those. We'll really be covering the service collection one because it's the easiest. Okay, so what are service lifetimes? So we've chatted a little bit around this, around the three different types of service lifetimes that we have, mainly being singleton, scoped, and transient. So the way I want you to picture this is we have an application and the application simply does something. So like let's say a really easy example is we want to be able to get a bunch of books from an API. And there's some sort of a book service that gives us the information. That book service has dependencies. Each of those dependencies could be something like a database or a repository pattern that sits within the service, that's injected into the service. Now, these injections happen in three different phases. So we can decide on what phase we wish to inject it as a whole throughout the application. If we choose to go with singleton, the singleton pattern says if this does not exist, create it. And if it does exist, simply give us that instance of it. So throughout the entire life cycle of the application, we'll reuse the same instance. While with a scoped approach, it will say, hey, every time somebody requests the books, create a new instance of the object and give them the same instance throughout that request. But if somebody gives us a new request, we need to recreate those objects, which is slightly different from what the singleton does because the singleton will reuse the same one over and over and over. Transient, on the other hand, will go and per request, it will go and create an instance of every single object that's there. So this is not very useful when we want to have maintain the state or we want to reuse something very often. This is best suited for very small applications that are not very state intensive. It doesn't care. It's very small. That's really when that's a more optimal approach. More often than not, we would opt in to use scoped or singleton. So yeah, just at a high level overview, when we register these services into the container, we need to be able to set those lifetimes so that the container knows, hey, this is the lifetime of the object. So that it knows, hey, if this needs to recreate it per request, does it need to maintain it throughout the entire application? Does it need to recreate each object throughout the entire service? So that's really at a high level what it basically does. It really controls the result object, how long it's lived, and again allows the container to dispose of them. So we've touched on sort of how it works at a very high level between the different types. So we can just go a bit more into detail to visualize how this would work. So here we have a request, and in the request there's a bunch of different services that need to be created. These services would create a new instance of every single object that's in that request. It's the most common, and it's really one of those things where we don't need to care about it if we multi-threading, but we have to really approach this with a very safe approach. We need to think about it before we just jump into this because it can be very inefficient for creating an object every single time if we don't have to. It's best suited for items like we've said that are not that doesn't care about the state of the application. It's okay if we just create a new instance every single time. So yeah, that's sort of how the instances would look throughout each of the requests. So that's really transient life cycles. So let's look at the next one. So this is how a scoped approach would work. So one service would create an instance and that instance would be used throughout the entire request, which is slightly different from what we saw with the transient, right? So if we come back to the approach of saying, let's say the book service or the order service and all of the dependencies that it has, such as the database, such as the repository, such as any other item that it might need, like shipping, it would create each of those dependencies every single time throughout the request, which is very inefficient if you think about it. While with the scope, it would create those services or those dependencies one time, and it would reuse that entire instances of those objects for the whole request. So if we, let's say, for example, get a book and then have to do other things with that same service, it would reuse the same instances as long as it's within the same request. While if it was with transient and we called that same service twice, like let's say we're getting the books and then we're getting a book or we're updating a book, it would create new instances of every dependency every single time. So it's not really the best approach when we care about the instance, where we care about the performance of how overall application works. It's generally not the best approach, especially when it comes to recreating objects over and over. It's very inefficient. So again, it's better suited for multi-threading, where each thread will go and create its own instance of the objects anyway. But generally, when we're dealing with this type of approach, we normally just use scoped or singleton just because of the safety and reusing the same objects. It tends to be more memory efficient, it tends to be able to maintain the state. Again, this is more for state driven applications. And then lastly, we have a singleton. So a singleton again will just create one service throughout the entire application. And that one service will basically be used throughout every single request that happens. So whether it's request one, two, three, four, five, up until n number, it will maintain the same instance throughout. It will continuously reuse the same servers. Again, this does also come with its own problems because over time memory leaks can build up and it can cause issues as well. But generally, it tends to be a much more efficient approach. Just because we're maintaining the state, we're not having to recreate an object all the time that is already there. The only thing to be wary of here is when it comes to concurrency and threading issues. Because we only have one instance, if multiple threads attempted to access this, they would not be able to because there's only one object, if that makes sense. So, yeah, that's really the difference with singleton, scoped, and transient. These are very important approaches because this is how we go and set this up within the code. This is how the DI container would just know, hey, I need to recreate these objects, or I don't. I need to dispose of these objects, I don't. And it would go about it in the same way to go and resolve it. So let's have a look briefly on how we can go about now implementing something like this. Okay, let's see. So here we have an example service that just goes and generates a random number. This random number underneath uses some sort of random and it just says, hey, give me the next random number. And then we have some sort of a processor that processes numbers and then we'll just print it out. We inject this into the constructor and then we set this into a private field and then we simply process the number. So we go generate a new number and then we print out what that number actually is. This is fantastic. It's a very straightforward service. So let's see how we would be able to inject this into the code. So here we simply go and say, hey, we have some sort of a random generator. And this just takes in a I random generator, which is the interface. So this is with what the mapping was that we were talking about. So this would go say, hey, we have this random number generator. And then we have a random number generator. So this is the interface and then this is the class. And then we would simply get that item from the DI container and then we would just process the number. So it's very useful when we have to do something like that where we need to go process it. Though I think in this instance we would have to create a new number instance. That's missing from here. So this would just be able to create the instance and then get the service. But this call actually would need to be on number processor. So there is a slight error there that we'll need to fix. But that's not the point. If we had to call this number as a whole, we would just be able to generate random number and then keep that there. So there is a slight mess up with this. So let's just see. So this is the correct instance of it. So here again, this is where we add the mapping. This is the container that we were talking about. So the container goes and says, please add a transient instance of this. So every time a request comes through, recreate every object that's required for this. So this will go and say, hey, for this interface, please give me this class. And that the container just handles in the background. We don't necessarily have to care about how it works. We just need to know how to use it. So then this goes and says, here's the transit number generator, get that random number generator, generate that number, and then simply just print out the item. And then the same goes for scope. So really the structure of it is very much the same. The only difference is the life cycle that we're giving it. So here this will go in the background and say, please add this as scope. So this will be reused throughout the entire life cycle of that request. And then we simply get that service and generate it. So we can see it's very much the same in terms of the setup on how we add the mapping. both scope, transit, as well as singleton as well. The only difference is just the life cycles that it will do. The collection and the DI container will just simply dispose of them according to the scope or the life cycle that we put into it. So here this will add it as scoped and this will add it as singleton. But the overall code structure is exactly the same. It adds it to the service collection, it builds the service collection, and then we able to get that service whenever we need to and then generate the number. So that brings us to the end of the dependency injection module in terms of the introduction and the theory and how that works. In the next module, we'll have a look at how we can go about implementing some of the more complex approaches and how this would work in the code, where we can see the power of dependency injection. And yeah, I'm excited to share all about it with you guys. I'll see you guys there. Cheers.